All right, flight 337, ready for takeoff. All right. Usually I use the microphone that's there, but I don't have it plugged in right now. So we are on this microphone. Aren't you guys excited? I'm excited. All right, I hate wearing a headset, but that's okay. All right, let's roll. Let me move this out of the way. Let's go this way. Let's go like that. And all right, so first lesson is really just getting us going. And the first thing is the idea of opposites and absolute value. Opposites and absolute value. And math, remember, everything builds. So we're going to build. We're making a building. And so we got to lay a foundation. All right, so the set of integers contain not only the positive natural numbers, but also the negative numbers. And this should be, you should have this knowledge already. By the way, basically when I write it, you want to write it, I'd use the same color. So what are the integers? All the positive numbers and all the negative numbers. Not a big deal. That's something you should be aware of. That shouldn't be anything that's, a surprise to you. How do you list the integers in set form? Okay, I'm going to start with dot, dot, dot. What does that mean? Somebody raise your hand. What does dot, dot, dot mean? Raina? Part of it? Kinda. Anybody know dot, dot, dot? Yes, ma'am. Say again, Madison? To be continued is a good way of thinking. It means the pattern continues. Well, let's write a few numbers. Let's go -2, comma, -1, comma, 0, comma. Let's go 1, comma, 2, comma, and go dot, dot, dot again. Okay, the three dots, by the way, are called ellipses. It's just their name. And it means the pattern continues on forever. So you guys know the next number after 2 is 3, and then 4, and then 5, and we can all count, right? Can you count? All right, if you can't count, go to the other class. All right, just teasing. All right, just teasing. But, so is a million an integer? Yeah. Is 10 million an integer? Yeah. Is a billion, zillion, gillion, illion, whatever other illion an integer? Yeah. What about -1,000? Is that an integer? Yes, that's why the three dots are on the left, right? It keeps going left forever, keeps going right forever. Is a half an integer? No. Right? The counting numbers 0, 1, 2, 3, and up, and -1, -2, -3, and down. So the positives and the negatives and 0 are the integers. Not a big deal. All right, integers in a number line. So you guys know, I hope you know how to do a number line. Some of this I assume you know, but I'm just making sure, okay? So when you got a number line, which way do the positives numbers go? Do they go right or left? Right. All right, good. So take your whatever color, blue if you want. So that would be 1, right? And therefore the next spot would be 2 and 3 and 4. And your positive numbers are getting bigger as you go to the right, correct? All right, so positives get bigger as you go to the right, and therefore negatives go to the left. So let's take I'm going to use red, -1, -2, -3, -4. And by the way, notice our arrow, our number line has arrows on both ends, right? Because do the numbers continue? Yes, but we're only showing part of it, and so we put an arrowhead at the end to show that really the number line continues on and on, forever and ever. Amen. All right, number 2. Let's finally get to opposite numbers. So opposite, O-P-P-O-S. I-T-E. Opposite numbers. All right, can you fill in the blank? Somebody raise their hand. Opposite numbers are two numbers where there's... Ooh, almost gave it away. Yes, sir. Not below. Not below. Madison, where their sum is 0. Right, operations in math. You guys know, what are mathematical operations? Somebody give me an example of a mathematical operation. John? Okay, what kind of operation is that? Addition. All right, so addition is an operation, and the answer to addition is the sum, right? So we're talking adding, right? Subtraction is an operation. The answer is the difference. Division is an operation, right? The answer is the quotient. And multiplication is an operation. The answer is the product. All right. So, but opposite numbers are two numbers where their sum is 0, so we're adding. So in this first example, 9 plus what equals 0? Michael? 9 plus -9. right? And 9 and negative 9 are opposite numbers, not a big deal, right? Because the two numbers equal 0. So in our second example, negative 2 plus what is 0? Class? 2. So negative 2 plus 2. So negative 2 and positive 2 are opposite numbers. So what kind of, in words, what can you tell me about opposite numbers in words? Without saying two numbers where the sum is 0. Kind of in just regular talk. What's the idea of opposite numbers? Anybody? Michael? Maybe. Not a bad thought. Not a bad thought. In other words, what do you kind of see about the aspect of opposite numbers? I mean, looking at the example, 9 plus negative 9, 0, negative 2 plus positive 2, 0. Opposite numbers, though their sum will always be 0, what else is always the case, Raina? Okay, that's kind of the idea. Can we say it a little bit differently? Can we say it a little bit differently? Brett? Yeah, that's the kind of idea I was getting across. Look, opposite numbers, they're always the same numeral, but one's going to be positive and the other's going to be negative. Always, right? Opposite numbers. One's going to be positive, the other's going to be negative. So C, all right, well, we got a decimal. Well, not a problem. What's the opposite of 6.5? Negative 6.5, right? Because the first one was positive and the second one was negative. So now let's get to algebra, because this is pre-algebra, right? Now, of course, this next question is impossible because it's algebra, and everybody knows algebra is hard, and everybody knows nobody can figure out algebra. So I'm sure you're not going to know the answer, but we'll try it. So if you have n, what's the opposite? Oh, wow, you guys are Einsteins. It's amazing. You know, this is supposed to be hard. This is algebra. Algebra is hard. Well, right, look, it's the same thing. One's positive, one's negative, right? So positive n, negative n. They're opposite numbers. You say, but what's the value of n? I really don't care. If n is 7, the other one's negative 7, and they're opposites. If n is 55, the other one's negative 55, and guess what? They're opposites. If n is negative 2.75, then the other one is 2.75, and they're opposites. Right? Because one's positive and the other's negative, and they're the same thing. Positive n and negative n, opposite numbers. Even though we don't know what the value of n is, it's okay. We don't need to know. We don't need to know everything. If your parents ever told you that, you don't need to know everything. Say, but why? Well, you'll know one day. All right, that's because they don't know the answer. No, they do. They just can't always explain it. So opposite numbers. Two numbers where the sum is 0. Now, there's another way of thinking of them, but I knew it was the first day, and I knew we got a lot of things to go through, so I'm actually going to pause right here.